Hello! Let's put together everything we've learned so far. The focus of this course is Model-Based Systems Engineering, or MBSE for short. MBSE is a methodology for designing systems based on conceptual models. Such models represent the system at various levels of complexity and evolve during the system's lifecycle stages. Using this conceptual model, we, the developers, as well as various other stakeholders of the system, are able to have an in-depth understanding of the system and communicate with each other clearly and efficiently. The model is like the blueprint of the system or product it represents. It is the source of authority that enables all the parties involved to be on the same page at all times. This way, we can progress with developing the system along its life cycle. When we say life cycle, we mean the stages that the system undergoes as it progresses from problem recognition and definition, needs and requirements elicitation and modeling, concept evaluation, architecting, detailed design, all the way to implementation, use, service, and retirement. For now, we just note that the model, when used properly, can prevent misunderstandings and future problems with system development. Object Process Methodology, or OPM, is a methodology and language for conceptual modeling of systems. It has several advantages. First, OPM is recognized as ISO 19450. Therefore, an increasing number of Fortune 500 companies use OPM to model their systems. Second, OPM has only one kind of diagram, Object Process Diagram, or OPD. Additionally, OPM makes use of Object Process Language, or OPL, which is a subset of Natural English. It is therefore straightforward, and the basics are easy to learn. A third advantage of OPM is that it is domain independent, or domain agnostic. This means that we can use OPM to model systems from any domain or from multiple domains. For all these reasons, OPM facilitates communication and shared understanding among the system stakeholders, customers, engineers from different disciplines, and other various stakeholders, such as public organizations and regulatory bodies. The elements of OPM are things and links between things. A thing can be either a process or an object which may have states. Things can be physical, real, or informatical, virtual. The links we have learned so far were aggregation participation and transforming links. Aggregation participation allows us to represent the whole and its parts, be it an object or a process. Transforming links connect processes to objects and allow us to represent relations of consumption, creation, or change in state. Every system has three aspects: structure, behavior, and function. The combination of system structure and behavior makes its function possible. The system structure is its what, the collection of system objects and how they relate to each other. The system's behavior is the how of the system, the collection of system processes and how they are connected to the objects and transform them. System function is the why. Why do the system processes transform objects? What is the cause and what is the effect of the transformations? In the case of artificial human-made systems, we can also add to the system's function the utility aspect. What was the system built to do and for whom? What is the value of the transformation and who benefits from it? Every model in OPM has two ways or modalities of expression: visual and verbal, or more specifically, graphical and textual. The graphical modality is called OPD, and the textual modality is called OPL. An object in OPM is represented by a rectangle with green contour, a process by an ellipse with blue contour, and states by round angles, rounded corner rectangles with gold-brown contours. The reason OPM makes use of both modalities is that humans process information in separate channels and preferences between the two modalities vary. In order not to overload the viewer of the system model with information, one should limit the number of items in any given OPD and OPL. OpCloud is a collaborative cloud-based environment for constructing OPM system models easily and efficiently. That's it for now. We will meet again soon, where we will travel to some exciting places